In today's class, we're going to be looking at matrix. The objective of this lesson is to define matrix, to know the order of a matrix notation, to perform matrix algebra, which includes addition, subtraction, and multiplication of matrices. We are going to look at determinant of a 2 by 2 matrix and determinant of a 3 by 3 matrix, and finally we're going to apply this knowledge to solve simultaneous equation in 2 unknowns and simultaneous equation in 3 unknowns. Okay, let's begin by defining a matrix. A matrix is a rectangular array of information. This information can be numbers, it can be words, it can be objects, but in our lesson we are going to focus on a rectangular arrangement of numbers which are enclosed within brackets. So we can have examples of matrices as 2, 3, 0, -1. When we have this kind of arrangement, a rectangular array, numbers arranged in rows and columns and enclosed within brackets, okay, we call them matrix. Okay, so if we have 3 minus 5, 4, 1, 0, -2, this is also a matrix. Okay, 4, 7, 0, this is also a matrix. 5, 3, -2, this is also a matrix. So a matrix is a rectangular arrangement of numbers which are enclosed within brackets. Okay, so how do we write matrix? This is what we mean by matrix notation. How do we write matrices? In writing matrix, the name of the matrix is denoted by capital letters, and then the generic elements of the matrix will be denoted by small letters. These small letters have subscripts that denote the location of each element of the matrix. So let's take for instance, we have a matrix, a generic matrix A, and this matrix, we're going to represent it by small letters with subscripts A11, A12, A21, A22. Okay, this subscript represents the row and the column that the element belongs to. So if we use these points to represent the 4 elements in this matrix A, we can see that these 2 elements, they are in row 1. When we move from left to right, we're moving in rows, and then this is row 2. When we move from top to bottom, we're moving in columns. So this is column 1 and this is column 2. This means that this element at this position is in row 1 and column 1. That's why we have A11. Okay, and then this element here is in row 1 but in column 2. So that's why we have this as A12. 1, 2 is in row 1, column 2. The element here is in row 2 but in column 1. So we have 2, 1. So 2, 1 means row 2, column 1. And then the element here is in row 2 and column 2. Okay, that's this 2, 2. So the subscript, the first subscript denotes the row, while the second subscript denotes the column. Okay, so if we're giving an example, a real example this time, and we have 3, 4, 0, -1. Okay, since this matrix is called matrix A, what that means is that the element at position A11, that is the element at row 1, column 1, is 3. The element at row 1, column 2 is 4. The element at row 2 and the first column row 2 column 1 is 0, and element at row 2 column 2 is -1. Okay, so this is matrix notation. Okay, the next thing we're going to talk about is the order of a matrix. When we talk about the order of a matrix, we mean how many rows the matrix has by how many columns the matrix has. So let's look at a generic matrix again. If we have a generic matrix A, which by now we should know that we'll have A11, A12, A21, and A22. Here we have 2 rows. This is row 1 and this is row 2, and then we have 2 columns, column 1 and then column 2, which means this matrix has 2 rows and 2 columns. So we'll call it a 2 by 2 matrix. Certain times we might have a matrix that is not 2 by 2. Let's take this for instance. If we have a matrix B, and B has A11, A12, A13, A21, A22, and A23. Okay, so this matrix here has 1 row, 2 rows. So there are 2 rows. We write 2 by, there are 1 column, 2 columns, and 3 columns. So it's a 2 by 3 matrix. The matrix has 2 rows and 3 columns. Okay, let's go back to our initial examples of matrices so we can check out how many rows and how many columns there are in each of the matrix. Okay, for the first example here, we'll have 1 row, 2 rows. So there are 2 rows by, here we have 1 column and 2 columns. So this is a 2 by 2 matrix. Okay, in this second example, we have row 1 and row 2. So there are 2 rows. Here we have column 1, column 2, and column 3. So there are 3 columns. So this matrix is a 2 by 3 matrix. Take note that it's always row by column. Number of rows first before number of column. In this matrix, we only have 1 row. Okay, only 1 row. So we'll say 1 by, here we'll have column 1, column 2, and column 3. Okay, so this is a 1 by 3 matrix. In this matrix, we have row 1, row 2, row 3. Okay, so we have 3 by, here we have column 1, just 1 column. So this is a 3 by 1 matrix. So take note, when we move from left to right, we're moving in rows. When we move from top to bottom, we're moving in columns. So count the number of rows of the matrix by count the number of columns of the matrix. That will give you the order of the matrix. Let's take a quick look at these examples, or these exercises. Okay, so we have this matrix A, which is given as 0, 5, 30, 25. We have 6, 2, 3, 6. We have -1. We have 0. We have 2. We have 10. Then we have 18. We have 16, we have 8, and we have 13. So what is the order of this matrix? Okay, as we already know, this is row 1, this is row 2, this is row 3, this is row 4. So we have a 4 by, let's count the number of columns, column 1, column 2, column 3, and column 4. So this is a 4 by 4 matrix. Okay, so let's take another exercise. We have matrix X, and this matrix we have 1, we have 3, we have 3, we have 4, 2, 8, 9, we have 30, we have 62, 62, we have 14, 30, we have 7, and we have 4. So what is the order of this matrix? Okay, so this is row 1 and row 2. I have just 2 rows by I have column 1, column 2, column 3, column 4, column 5, column 6. So this is a 2 by 6 matrix. Okay, so remember it is read the number of rows by the number of columns, but in writing we write it as number of rows times the number of columns. So let's look at addition and subtraction of matrices. Addition and subtraction of matrices. To add or subtract two matrices, we have to take note of two things. Number one, they must be of the same order. The two matrices we want to add must be of the same order. And number two, we are going to add elements at corresponding positions. Okay, so let's take example. Find the sum of these two matrices. Here we have 3, 5, -1. Here we have 6, we have 7, and we have 11. Okay, in this case the operation is plus, and then we have 2, 0, -4, and then we'll have 1, -3, and 5. Okay, to add these two matrices together, are they of the same order? Let's check. This matrix, the first matrix here, has 1 row, 2 rows, and then 1 column, 2 columns, 3 columns. So this is a 2 by 3 matrix, 2 by 3. In the second matrix, we have 1 row, 2 rows, that's 2, 1 column, 2 columns, 3 columns. So it's a 2 by 3 matrix. So both of these matrices have the same order. They are of the same order. So we can go ahead and add. And then what do we now do? We say we add elements at corresponding position. Remember how we did positioning? This is the element at A11. This element here is at A11. And this element is at 112. So we're going to add 3 plus 2 for that position. Okay, this element is at A12. This is A12. So add 5 plus 0. This is position 1, 3, row 1, column 3. This is row 1, column 3. So we have minus 1 plus minus 4. Okay, here we have row 2, column 1, and this is row 2, column 1. So we have 6 plus 1. This is row 2, column 2, and this is row 2, column 2. So we have 7 plus minus 3. This is row 2, column 3, row 2, column 3. So we have 11 plus 5. Okay, we're adding elements at corresponding position, the same position. So here we're going to have 3 plus 2 as 5, 3 plus 0, 5 plus 0 as 5, minus 1 plus minus 4, that is -5, 6 plus 1 is 7, 7 plus minus 3 is 7 minus 3, which is 4, 11 plus 5 is 16. So when we add these two matrices together, what we get is 5, 5, -5, 7, 4, and 16. Okay, so take note of the two rules. Make sure the two matrices are of the same order. You cannot add two matrices that are not of the same order. So make sure the matrices are of the same order, and then add elements at corresponding positions. Okay, so let's take one more example. In this example, we have the A is equal to 16 and 4 minus 3 and 12. B, matrix B has the elements 10, 8, and then 5 and minus 4. Okay, the question says we should find A plus B, and then we should find B minus A. Okay, so let's find A plus B and B minus A. So A plus B is going to be 16, 4 minus 3, 12, plus our B is 10, 8, 5, negative 4. Okay, they are of the same order. This is a 2 by 2 matrix, and this is also a 2 by 2 matrix. So what we do now is to add elements at corresponding position. This is position 1 1, and this is position 1 1, row 1 column 1. So we have 16 plus 10 at position 1 1. That's the first position. Okay, so we add elements at position 1 2, row 1 and column 2. So we have 4 plus 8. Okay, this is position 2 1 and position 2 1, minus 3 plus 5. This is position 2 2 and position 2 2. We have 12 plus minus 4. Okay, in this case, all we have to do is to compute the addition at the various positions. So 16 plus 10 is 26. 4 plus 8 is 12. Minus 3 plus 5 is 2. 12 plus minus 4 is 12 minus 4, which will give us 8. A plus B is 26, 12, 2, and 8. So we'll quickly look at B minus A. B minus A. So matrix B minus A will be right matrix B, which we know as 10, 8, 5, negative 4. 10, 8, 5, negative 4. 10, 8, 5, and negative 4. Minus, okay, matrix A is 16, 4, minus 3, and 12. Okay, so this is it, guys. What we have to do right now is to subtract elements at corresponding position. The same thing we do for addition, but right now it's just subtraction. So position 1 1, this is position 1 1, position 1 1. So we have 10. The operation is negative, and we have 16. This is 1 2, and this is 1 2. So we have 8 minus 4. This is position 2 1 and position 2 1. So we have 5. The operation is minus, but the number is also minus 3. And then we have this position negative 4, and then the operation is minus. This position here is also 2 2. So we have minus 4 minus 12. Okay, all we have to do is to compute this subtraction at different positions. 10 minus 16 is minus 6. 8 minus 4 is 4. 5 minus 3 is 5 plus 3, which will give you 8. And minus 4 minus 12 is minus 16. Okay, if you find it difficult to compute negative and positive numbers together, I have a lesson on directed numbers. Check for it around my channel. You're going to find a lesson on directed numbers, and you get to know how to add negative and positive numbers very efficiently. All right, in our next step, we're going to be looking at multiplication of matrices. In matrix multiplication, there are two types of multiplication. The first type is we'll multiply a matrix by a scalar number. Okay, well, we'll multiply a matrix by a scalar number. What we mean is a matrix is multiplied by an ordinary number like 4, ordinary number like 8, ordinary number like 12. So take, for instance, if we have solve 4 multiplying a matrix 2, 6, -1 and 0. Okay, so this is a matrix and this is a scalar number. We'll call it a scalar number because it's not a matrix. Okay, so when a matrix is multiplied by a scalar number, what we do is we use that scalar number to multiply each element of the matrix. So 4 multiplying 2, 4 will multiply 6, 4 will multiply -1, and 4 will multiply 0. 4 multiply 0. Okay, in this case we are going to have 8. 4 times 6 is 24. 4 times -1 is -4, and 4 times 0 is 0. So this here is scalar multiplication of a matrix by a scalar number. Okay, let's take another example. Given that A, matrix A is equal to 2, 6, 4, 1. Okay, matrix B is equal to 12, 18, 14 and 16. And then we'll have a matrix C, which will have a matrix C. Matrix C is equal to 1, 5, 4 and 2. Okay, this is matrix A, B and C. And then our question is saying we should find 4A plus C, and then 2B plus C. Okay, this is very simple. What that means, get the addition of matrix A and C and then multiply your result by 4. Okay, so to solve this, what we're going to have is 4A plus C will be, we'll have 4, and we're going to multiply this 4 by whatever we get from adding A and C together. So in this case, our matrix A is 2, 6, 4, 1. Okay, plus our matrix C is 1, 5, 4, 2. 1, 5, 4, 2. Okay, so this is our matrix. Let's solve this now. Okay, so what we're going to have, let's begin with the innermost bracket, or the matrices that are inside the bracket. So we'll have 4, okay, and then we'll have this. Remember, we're going to add elements at corresponding position. So 2 plus 1, 2 plus 1, then 6 plus 5, 6 plus 5, 4 plus 4, 4 plus 4, and then 1 plus 2, 1 plus 2. Okay, in which case we're going to have 2 plus 1 is 3, 6 plus 5 is 11, 4 plus 4 is 8, 1 plus 2 is 3. Okay, now we now have one matrix and one scalar number. So what we're now going to have will be 4 times 3, 4 times 11, 4 times 8, 4 times 3. In this case, we're going to have 4 times 3 will be 12, 4 times 4 is 44, 4 times 8 is 32, 4 times 3 is 12. So 4 in brackets A plus C, 4 in brackets A plus C is equal to 12, 44, 32 and 12. So this is our matrix we get. After adding A plus C, we multiply the result by 4.